Hello, I am James Walbright, and we are Team Solar Mist. Our project is a solar-powered automated irrigation system. This project will allow the use of center pivot irrigation systems in locations where traditional power is not accessible. I have been working on constructing the demo day box to display the model of our center pivot design. I have also been designing and 3D printing the center pivot components. I have been testing the design with the irrigation plumbing that will be used to distribute water to our sod example. An electric valve will be used to control the flow of water to the center pivot mechanism. I will also be working on determining the inverter needs of the system based on the final power amounts. And now, here's Mallory.
Hi, I am Mallory Herrera and I'm working on the sensors. Our design considers rainfall, wind speed, and soil moisture to deliver a customized irrigation schedule. I have been working on designing the circuitry for the sensors to run off. I have ordered and received all sensors and have determined the correct dip switch configuration for the infrared rain sensor to create the best process to collect data. Our sensor will work in rain collection mode, sending a pulse every time 1/100 of an inch of rain is recorded. This pulse will allow the Arduino to keep track of the total amount of rain fallen to determine if a change in irrigation will be required. A check will be done with the actual sensor to determine accuracy and best ways to proceed. Wind speed is being determined based off voltage readings induced by the sensor and will have a customizable max speed based off irrigation location. Here's Will with more information.
Hello, I'm Will Warren, and I'm working on the programming of the controllers. We're using Arduino tied into a Raspberry Pi to control the sensors and their overall system, the pump, the valve, etc. The main program will take readings from the soil moisture sensor and record the most current water levels within the irrigation fields. Multiple sensors will need to be read based on the size and types of soils and the locations to be irrigated. The voltage readings are read from the wind sensor and equated into meters per second. This wind speed is then compared to a predetermined maximum speed to decide if the optimal irrigation parameters are being met. The program will also control how long and when the center pivot motors are to be ran based off of the readings from the sensors and the inputs from the user telling it which type of crop is to be irrigated. Here's Christopher with more information.
Hi, I'm Chris Rich, and I'm working on the pump and elevated storage tank portion of the system. Testing has been done on the physical pump to validate the calculations determining power needed to pump to the required height. It was decided that an elevated storage tank system would be used, reducing the energy storage needs and associated battery costs. The system will pump water into the elevated storage tank throughout the day while the solar panels are delivering power. Flow of water from the tank will be controlled by an electric valve with the flow rate determined by the head pressure from the height of the storage tank, the amount of water, and the size of the plumbing. Water will be released to flow during the designated irrigation times, allowing for the minimal energy storage to be used only by the center pivot motors when no solar power is being produced.